Hello, welcome back. Let's head to OSPF lab. So here we have the same topology, and we just eliminate all the configuration, routing protocol configuration, and then leave all of the interface configuration, like IP addresses. And now we get started. Before we get started enabling OSPF protocol, we just remember we need to give every router a router ID. And route ID, for route ID, you can explicitly assign a route ID within the routing OSPF routing protocol configuration. And you also can have or define a loopback interface with an IP addresses as a node ID. So here, just create a loopback interface with IP address 1111, and down here. So this is a route ID. I will just enable OSPF. One means is autonomous system ID. You just means that it's a process ID. You can have many OSPF processes that are separated with each other. So then you give a network, and you just type in the IP subnet that includes all of your interfaces where you want the OSPF protocol enabled. So here is give it you can give it wildcard net mask. So you can give wildcard net mask and give it area ID. And you also give it 172.16.10 1.0 and 0.0.0 down to 55 area 1, which is including Ethernet 0.1, right? And same thing, you give 3.0, which includes Ethernet 0.2. And stand for this configuration, and we can show because you don't have now you don't have any OSPF adjacency, so you only can see this is on RSA because there's no any neighbors creating now, so it's just only there's their own RSA coming out. So if you want to get into that, so OSPF database and router and 1111, you can see the RSA the detail of this RSA. This record is called one RSA, and Okay, I just spent a little bit of time typing in all of the configuration, including creating a loopback and also enabling OSPF. So we can just show something. Here we can see that when all the configuration is typed in, we can see the interface status will change. Or you can see, just remember that for establishment of adjacency relationship, we have 7 states. So full, from loading to full is the last state. That means if you show OSPF neighbor, we can see R2. Just you can see from R2 in terms of R2, it has 2 neighbors, adjacent neighbors, which with the state full state. Full state means that everything is going well. So the neighbor ID is root ID is 5555, which means R5. 4444 means R4. So you can see that 4 and also BDR. That means that for this data link, 5555 is BDR. R2 is DR. For this data link, 4444 is BDR, and R2 itself is a DR. So it's just show OSPF protocol, or just show neighbor 4444 detail. So you can see DR is 172.16.3.2, which is myself R2, and BDI is 5, so R5. And also you can also check 4444, and for this data link or Ethernet 0/1 data link, me is also ADR, and R4 is a BDR. So you can just realize or understand how DR and BDR are elected. And this is an interface status and OSPF neighbor or adjacency relationship. And you can show IP OSPF database to see all of the RSA. Bear in mind, every router has to have identical topology or graph. So you can see from R2's configuration, there's 8 RSA, 4 router RSA, 4 network RSA. And if you check the same database on R3, it has identical RSAs. So everyone has identical topology and graph. So based on that, every router just involve SPF algorithm or best path algorithm to figure out a best path for every specific route. So those routes will be inserted into routing table, which is here, shown here. So for example, from R3 point perspective, when it wants to reach to 00 subnet, it has to route because it is symmetrical from upper pass, from lower pass. They have pretty exactly the same metric, and also OSPF had the AD administrative distance, which is 110. So you can see other OSPF route with a denoted by O. So for two perspective, we can also show the same thing happened for 5. For 5 subnet, 5.0 subnet, they have 2 routes. So if you want to pin something, pin 172, 16,500 -T. So this is from the pin is from VPC 1 to VPC 5. So now it just hold up R5, give it a failure on Ethernet either 00. I just shut down this interface. So you can see the convergence time is totally different. Right? And we R5, we just can recover this. No shutdown, and this. If you hit no shutdown, there's no disruption here. So everything's work fine. So that's OSPF configuration. Very, very simple configuration with simple area. Single area as area 0. So just if you want to go deeper, just check out OSPF database. Database the meat of OSPF protocol. So for area 0, they have 4 router RSAs. For area 0, they have 4 network RSA. Who originate this network RSA? DR. I didn't mention that, but every DR on behalf of this data link will originate a specific network RSA. So if you want to go deeper and show, database, show network, and give it the link ID 1712, you can see the content of the RSA. That's it. That's everything for this simple lab.